All right, so this is number 86 out of the homework packet. And the direction says to find the slant asymptote of the graph of each rational function and follow the 7-step strategy to use the slant asymptote to graph each rational function. So we're going to do just like we did previously when we graphed it, but this time we're just going to add in the slant asymptote when we're doing our other asymptotes, okay? So let's go through. I'm going to let my step 1 still be find my domain. So what is my domain? How do I find it? Yeah, my denominator cannot equal 0. So x minus 1 cannot equal 0. Solve for x. So x cannot equal 1. So if you need to draw your number line, do so. So x can equal 1. Put your infinities, which means it can equal everything else. So our domain then is what? Well, it's this interval and this interval, right?
Negative infinity to 1 union 1 to infinity.
Good. Okay, step 2, we're going to find our vertical asymptotes and our holes. So this means I need to see, can I factor this? So in my numerator, I'm going to see if I can factor that. Is there anything that multiplies the 1 that will add to 1? No, because 1 times 1 is 1, but 1 plus 1 is 2. So this isn't factorable. So no factoring. All right, so does anything cancel? No. So what does that mean?
Nothing. You got no little holes.
There's no holes. Because remember, those are only factors that cancel. And if nothing cancels, there's no holes. Do I have anything that in the denominator that did not cancel?
X minus 1.
All right, so vertical asymptote is when it's set equal to 0.
X equals 1.
So x equals 1. Remember, these two together combine to make up that restriction that you had up there in the domain, okay? So step 3 is our horizontal asymptote, and we're going to add in our slant asymptote. Because again, it's one or the other or neither, okay? But it'll never have both of them. How do you find your horizontal asymptote?
The top.
The highest power of x. So when we look up there at the problem, where is our highest degree? It's the x squared, which is on top. And we said if it's on top or bottom, we're going to use no. What did the n on top stand for? None. Since there's not a horizontal asymptote, I need to check and see, does it have a slant asymptote? How do we know if it has a slant asymptote? Yes, the highest degree is on top, and it's 1 bigger than the bottom. So we already said it's on top, right? That's how we got none. But is it bigger than the degree on bottom by 1?
But do you include the other x on top?
No, just the largest on each one of them. So we have a 2 on top and we have a 1 on bottom, correct? So the top is bigger than the bottom by 1. So that means, yes, we have a slant asymptote. How are we going to find it? Division, right? So then can I use synthetic division or do I have to do long division? Synthetic division, why? Because it's x minus 1. All right, so no x squared on bottom, no fraction, no number in front of the x. So we can use our synthetic division. What number is going to go on the outside? The 1 from the x minus 1. What number is going to go inside? Wow. Yes, yes. All right, so my coefficients, right? I had 1x squared minus 1x plus 1. Underneath here, I'm going to put my remainder box. So bring down the first term. Anything on bottom gets multiplied by that number outside on the left. So what's 1 times 1? Combine them. It's -1, and it's a positive 1, so it's -1 plus 1. Times 1. Oops. Combine them. All right, so we get 1x plus 0 plus 1 over x minus 1, right? What are we going to do about that remainder? Don't worry about it. So we get y equals 1x plus 0. Can I simplify that any?
Just remove the 0.
Yeah, it's just y equals x, isn't it? But if you want to, you can leave it as y equals 1x plus 0. It might make it easier when we actually go to graph that. All right, step 4 is our x-intercept. How do we find the x-intercept? Our numerator equal to 0. But we already said we can't factor that, right? But I have to solve for x. So what's my other option? Quadratic formula. So what is my A? My B? And my C. All right, so we're doing our quadratic formula here. So do you remember it? Good. All right, so I don't know if that could be heard. It was x squared equal, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So let's plug in our pieces. So negative b plus or minus square root b squared minus 4ac all over 2a. And we're just going to work this out. So what's a negative 1? So 1 plus or minus the square root of 1 squared is 1. And we get minus 4 all over 2. Now, we're looking for the x-intercept, and it's got an I in it. So, where is I on my x-axis? Nowhere. So that means it's not going to cross the x-axis, okay? So, my x-intercepts, there are none. Five is my y-intercept. How do we find it? Set x equal to 0. So we're going to find f of 0. Or 0 squared minus 0 plus 1 over 0 minus 1. So 0 minus 0 plus 1 over negative 1. 1 over negative 1, which is negative 1. So I have a y-intercept at 0, negative 1. All right, so we're going to graph this. Oops, you can't really see my 9 on the thing there, so there's a 7 that helps. All right, let's plot what we've got here. Let's see, we have, okay, do domain. We have a vertical asymptote at 1. All right, we have a slant asymptote at y equals 1x plus 0. So I'm going to come over here. It's kind of next to it here, and let's talk about that. So y equals 1x plus 0. What is my slope? 1 over 1, which means we're going to go up 1 and right 1. Or if I can't go up anymore, I would go down 1 and left 1. And my y-intercept, that's my starting point, is where? The 0. So when I go to graph this, I'm going to start at 0, and I'm going to go up 1, right 1. And guys, this needs to go like your entire graph, okay? So just do your best on it. And we're going to go down 1, left 1. Remember, this is an asymptote, so we're going to draw it as a dashed line. So I'm going to make all my little points dashes. Everybody okay with that? Then if we keep going, we don't have any x-intercepts, but we have a y-intercept, excuse me, sorry, at negative 1. All right, let's set up our interval table here. So we're going to have our interval. Our x value, our y value, and then our sign. Now what do I use to find, excuse me, what do I use to find my intervals? X-intercepts and vertical asymptotes, okay? So slant asymptotes, even though it crosses the x-axis, are not used here. But you can see then you have from negative infinity, you have a vertical asymptote at 1. And then from 1, we go on to positive infinity. So pick an x value. What's the number between negative infinity and 1?
Negative 1.
Okay. And between 1 and infinity?
1.
Between 1 and infinity?
2.
2. So let's go plug in negative 1. I'm going to do it right below my table here. Oop, that's minus x, isn't it? Okay, we're going to work that out. So negative 1 squared is 1. What's a negative negative 1? So plus 1, what does that give me? So 3 over. On the bottom we got negative 1 minus 1, which is, so negative 2. I'm sorry y'all, here in class you cannot see, it's written on that black thing on the side of my thing, but it's 3 over negative 2. Guess I could write below it there. I don't have enough room for the other problem anyways down there. I'm going to have to do it above it.
Do it right there on the bottom left.
Which means it's going to be a negative 1.5, right? Alright, yeah, so I'm going to come over here and I'm going to do that other one for my table there. We're going to find f of 2. Plug 2 in, we said, for our x value. So I'm plugging it in. I'm going to work out my numerator. So 2 squared is 4 minus 2 plus 1, which is 3. And then on bottom, 2 minus 1 is 1. And 3 over 1 is 3. So we're going to graph those ordered pairs. So negative 1, negative 1.5. 2, 3. Okay, so we go to graph this. I'm going to come out of that blue dot that I have on the y-axis, the y-intercept there. As I go to the left, I'm going to go through that pink dot, but I've got to be shaped, got to be shaped by that asymptote. So I'm just going to kind of go along it. I'm really getting closer to it piece by piece, but I can't cross it, okay? Now, look back up there. So as I'm going to the right, can I cross that x-axis right there? No, I don't have an x-intercept. I can't cross the x-axis, can I? Whoops, went too far there. All right, so that means I'm going to have to go down. Are you looking? And again, I'm going to be shaped by that asymptote that's right there. I can't cross it. Then when I look at that top point, do you see how it's just kind of trapped up there? So it's just going to be shaped by the asymptote. As it goes to the left, that asymptote is going to force it to go up. It can't go down because it can't cross the x-axis. And as I go to the right, that slant asymptote just kind of forces it to go on beside it as well. And so there is the graph of our function.